Okay. Okay, yeah, sure. Good morning, everyone. My name is Ann Klein. I'm a member of the tax planning team. And I wanted to let you know that I'll just be monitoring the session today. You'll have a presentation. There'll be time for questions and answers if you have. So I would like to introduce to you Yong and Dr. Mohamed Abusharkh. They're going to be presenting on Ferris Data Science Virtual Lab. All yours.
All right, morning everyone. Okay, so today's topic is regarding the data science virtual lab. So we are going to talk about the basic ideas of why we have the passion, okay, to start the lab. What's the purpose for that? What's the relationship between the lab and the prospective and master programs? You guys have any questions, you can ask at any time, okay? All right, so here's some background. Why we have the passion to establish these master programs. So for instance, data science or data analytics has been considered or listed as the top 3 jobs in American for 6 years in a row, okay? And in 4 of those 6 years, it actually ranked as #1 job in the US, right? The interesting part is, from 2 sides. One is why market has such a high interest or demand regarding the major, regarding the career. Okay, and second is what we can do, how we can supply enough students, right, to meet this demand. Okay. For instance, in 2019 alone, job listing increased about 37%. And that's a lot, okay? Because if you guys are familiar with how compound interest is calculated, if something increased about 30–40% per year, in like 10 years, you can like triple it very easily, okay? All right, and also the estimated salary increase in that year will be around 4%. Again, compound interest. You can tell that not only the job listing increase a lot, the compensations, the monies in the field also increase quite dramatically. Okay. In 2020 alone, we have about 250,000 job shortage. And if you do the math on average, okay, on average, this is a pure shortage. On average, we have around only like 50,000 students who can graduate. And this is after the fact, all of them like already got the job. We still have almost 5 times more jobs opening and which need students from the field, okay? All right, so therefore, there's a high demand, okay, for both professional skills and the degree seats. And therefore, we have the passion to see, hey, how about let's create enough trainings so that more students can get the benefit in that field, right? All right. So how about last year? Okay, in 2021, the median salary in that field is about $113,000. Okay, and also it's considered as the 2nd best job in US. This year, the data is very new. I just got that very recently. Okay, because we barely entered 2022. The average salary has already increased to 135. Okay, And according to US Bureau of Labor Statistics, if you are a data scientist, right, and you work in like computer related field, your average salary is more than $143,000. If you consider for all majors, that average, same standard is about $53,000. Again, it's very easy math. We almost triple it. Okay, and that's the government link come from. So yes, we aim to establish this online master degree. Okay, very obvious reasons. And to make that happen, we will construct a virtual lab to support it. All right. Any questions? All right. So I will let Mohamed to take over.
Thank you. Good morning, everybody. I want to ask a question first. So we hear the word data science. We saw a lot of promising salaries. What type of image comes to your mind when you hear the words data science, AI, data analytics? Start it off. What image? Let's close our eyes. Image.
Knowledge.
Knowledge. All right. Increasing insights. An image of a product. What type of product is it?
Probably programming.
Lots of hours programming, yes. Don't remind me of the suffering. All right. Other images? And products that come out of data science. Which fields do you think this is valuable for?
Yes.
Yes, that's correct. All right, that's interesting. Can you tell us a bit more?
Map making.
Yeah, correct. All right, interesting. Other ideas?
Autonomous cars.
Autonomous cars. Excellent. This is, data science is making them happen really, really soon.
Security.
Security, very, very important. Analyzing data is critical aspect for security. Other fields? Finance, health, insurance, engineering, factories, all over. Everything's changing because of data science. Let's take a look at this job or field, or what does it mean, like when we say data science? What type of jobs? What do we do as data scientists? So basically, obviously it's about data. We're collecting a lot of data these days, as we're collecting as a species. We're tripling and doubling, and collecting data not in the terabytes, but in the petabytes and then exabytes as well. A lot of data is being collected. There's around 50 billion devices that are collecting data on Earth. And we just can't fast enough get insights out of this data or process this data. That's what we call big data. Why did we call it big data? It's not just because of the size. It means that the size, the data we have now is just bigger than every tool that we've ever had, and it's not able to process it. So we have to come up with new models and new tools, and we have to have new engineers or data scientists to process them. And that's where the demand is coming from. Let's take a look a little bit at this cycle. So we start with collection. We have tools, and each tool is tied up to skills. So if we talk about the job market, and also if we talk about the educational market, or what do we teach at Ferris, what should we teach at Ferris to match the job market, that is the cycle here. So there's data collection tools. So first, the data sets. This is the source of power for any model. Any model is only as good as the data that we process it with. That's why if I build a machine learning model to recognize audio or try to recognize speech, for example, like Siri or Google, or when you say, okay, Google that model, my model will not be as good as Google's, even though I might be using the exact same algorithms, the exact same techniques, because the size of data that they have is way bigger than I am. So, excuse me for a second. No. So the sources for the data sets or collecting data is a big deal with big data and data science. There are websites that you might have worked with, like Kaggle, JotForms, and UCI, Stats, a lot of websites that collect data. And this is very, very valuable. Now, next is storage. We're talking about traditional database tools and also NoSQL database tools, and also new tools that we call big data tools like Hadoop, Hive, and other tools like that. So this is how you query the data, search for information within the data. You're just storing and searching. Next is basically the cleansing and pre-processing. The data is not always clear. You're getting a data from a sensor, has a lot of text, not exactly the information that you want. So we need to do some programming to clean it up, to be able to search it, do some pre-processing on it, organize it, make it in an efficient way. And then the gold mine here. The gold mine here is the insight extraction. You have a ton of data. You have data for every student in the US. You have data for all the weather observations in the US over the 30 years. You have data for every oil rig in the world. Yes, you have raw data here. How can you extract insight? So these are the tools that we build models for and try to extract insight from. And then finally, making it consumable for end user. So we're going to look at visualizing it, making it really nice, making it usable, building dashboards, building decision support systems, and basically giving it to executives and business leaders and educational leaders to actually benefit from it without having to have programming background or technical background. So that's the cycle for data science. In terms of the fields, like you said, tons of fields: image processing, autonomous vehicles, a million applications in text processing. This is a huge field now. Products like Grammarly, that we all see the ads for it. Products like machine translation, automatic translation. Products like extracting insight from statements or sentences automatically. This is all a reality. So what is our plan at Ferris? Our plan is to supplement the programs that we already have. We have a very strong base for data science. We have multiple programs interested in it. The software engineering program, which I'm the chair of, and it's out of Grand Rapids. The data science, business data analytics program here, information security and intelligence. There's multiple programs interested in this area. And we're supplementing that by a master's degree that is focused only on data science and to graduate students that are basically tailored, the knowledge is tailored for the industry demands. So that's the check sheet. You can find it very soon online, and you can ask us questions about it if there are any questions. I'll leave it here for a second, leave it for everybody to explore, and if there are questions on here.
To supplement my colleagues saying regarding the data in, let's see, in insurance company or finance, just some, again, data to share with you guys. So when we talk about the change, okay, in the financial areas, many of you guys are from business school, right? So how many of you guys from business school? 3 okay, good. So we can tell, this very related, like for example, bankers, right? Or people who work at a bank. So one information to share with you guys is kind of like a bad news in a way. In the last 3 years, okay, in the last 3 years alone, we lost more than 50,000 jobs in the banking system worldwide. In Germany alone, they lost more than 18,000 jobs in the banking system. So in other words, it's not about the wolf is coming. We already entered the area, okay? And then people estimate in the next 20 to 30 years, more than 60% of the jobs is going to be like almost millions of jobs going to disappear in the banking systems. Same thing already happened in America, like Bank of America and Wells Fargo, they already begin to lay off many employers every year. Why is that? Well, because of the automation, because of the data, okay? And then there's another survey. They asked many new students, graduate from law school, right? And asked them, if you have the choice to choose, like some skills or some degrees, you're more than, happier to pursue with, which one it will be? Guess what? Answer is AI. It's not another law training or business training. Like for instance, MBA used to be a very popular one, but now the number one answer is AI. So in other words, the world is changing and we have to change with it, right? Everyone okay with that? So for instance, you can see in our design, we have machine learning foundations. We have a programming for data science. We have a virtual data analytics and applied master together with data mining and predictive analytics. They are all related with combined AI, which is the first one, combined with programming, coding, combined with database, which is big data. And then from the three fixed concentration and one more like elective concentration, you can see we have the AV one, autonomous vehicles, right? One application we'll talk about. Especially in Michigan, it means a lot because we are like the car capital of the world, right? So autonomous vehicles, we have a business intelligence concentrations, again, very combined, closely with business school and project management, okay? And you can see why we want to design that way. So in other words, students can choose any of the full concentrations here, plus the 7 classes, total 10 classes to get a master's degree. And again, to make that happen, we now propose to have this lab currently already running, and we hire students to support them to do research, to accumulative materials, which is in real life, using real data and develop the real products, okay?
Excellent, thank you. So the innovation project that we're about to show you the demo for basically has 2 objectives. Our goal is to start a data science virtual lab at Ferris. The need for that is, of course, to support the student, to support the degree, to have models that are ready. Students will learn the skills, but if you have models and data sets that are ready for you, you will learn more, you will be ready to be very, very close to the skill set that the industry needs. Now, the plan for it is basically we want to build and evaluate multiple field-specific, less generic models. Like I can teach data science with just a small model with 10 data lines and just try and predict, apply linear regression and try and predict. That is good. That is good for the skill. But if I give you a data set that's 30 gigabytes of banking data, that is much more valuable. That way, you can take the skill and you can take the domain knowledge in the banking as well and go to applying in the banking, get a data scientist job that is, as Dr. Shou said, replacing traditional banking jobs. So that's the plan here. Our goal is to build multiple models that are kind of spanning multiple departments at the university, collaborate with subject matter experts who are colleagues and faculty at Ferris, and then hopefully we can have that open and ready for students to use as a tool that is open for everybody. Both the models and the tool itself to build your own model will be ready and available for. So our methodology is basically to build standard models, prototype applications to show you what data science can do with some data sets, different fields as we said. So maybe medical applications, sales prediction models, image recognition and repair, natural language application or text application. So eventually our goal by the end of this project is to make it available to clients and students online. So what we built is the Ferris Machine Learning Insights tool. So it's a tool basically where you can upload your data, build a model with a drag and drop buttons with basic functionality of machine learning models. You can control it, you can run it, you can get prediction out of it, and you can store your model. And as we are building the tool, we're building like exemplary models with it to kind of show you what we can do. Our software engineering senior student, Jacob Goeldel, one of our top students at Ferris, has really been on the lead with building the tool, and he's ready here to show us what the tool can do. And Jacob, you can take it away when you're ready.
Yep, let me share my screen. All right, can you see this?
Yes.
Cool. So this is the website that I've been working on. It lets you.
Just a second, Jake.
Okay.
Thank you.
Excellent. All right, go ahead.
All right, so this is the website that I've been working on that lets you try out machine learning models and create your own. So first, let's look at some of what you can do. First, we're going to look at a traffic sign classification model. So you can imagine with autonomous vehicles and stuff, recognizing what traffic sign is which is probably pretty important. So what we have here is that you can upload an image. Let's say a stop sign. So we have this image of a stop sign. And we'll upload it and predict. And we'll see what it comes up with. First one takes a little while. Yeah, I guess another important note for this model, as Mohamed talked about, the data is really important. And as it turns out, one of the biggest data sets that's available for free for stop signs is from Germany. So yeah, well, let's see here, predicted stop, and then it's 99% confident that it's a stop sign. So it's really, really sure.
So Jacob, to add to that as well, so how this works is basically the system trains on a large data set of all types of stop signs, and this data set comes from Germany. So basically, the data set has an image and then the type of sign. So an image of a stop sign, and then the type of sign says stop sign. Image of a yield. An image of whatever, speed. And then the model recognizes the image, how it looks, and tries to match the next image that we feed that maybe for a stop sign in here in the US. It just matches that and says, all right, this looks like this is the closest image. So there is no explicit programming or what we call standard automation. We don't go and say, if you see it as a red image and has the letter S, it stops. It's not. Basically, we're matching images, we're recognizing patterns, and how this is how this model works. And the last note here, notice it kind of gives us the prediction and gives us the confidence. So in this case, it's kind of pretty sure that it's a stop sign.
You guys probably noticed it's indeed take a while because we actually generate that live. It's not like we already pre-record that or we build already. And then, for instance, you can use like the system trained in one country and use another countries here and still work. Like for instance, you probably use another country, like say from Spain, and put it here. It's probably in different language and it still can recognize.
All right, go ahead, Jake.
Yep. So just to try another one, this is it's a bit tiny, but the 30-kilometer sign. So we'll try that and see if it can figure that out. And it does, and it's extremely confident about that one. And then just to mess with it, we're going to try an image of a cat, something it hasn't trained on.
The second time is much faster because system already been loaded. So in other words, the model already in active standing mode, it will be much quicker.
Yeah, it does take a little while to initialize the model for the first prediction, but after that, it goes pretty quick. So yeah, let's try this, see what it does. Apparently, cat is a right-of-way next intersection sign. As you can see, it's way less confident about that. So
Not sure about it's 50-50, but if you really want me to guess, maybe right of way because there's a cat.
yep.
Or maybe dog will be the left dog way, right?
All right, so let's try another demo. We have a housing price predictor here too. So with this, it's based off of California data. So obviously prices are going to be a little higher here, but so for this model, you just enter an age, number of bedrooms, and number of rooms, and we'll see what it says. We'll say it's 40 years old, has 2 bedrooms, say like 6 rooms or something, and hit predict. And in this case, it says 193,000 for the house price. Now, for the house price one, I can actually show you how this is made because this is made with the online tool. So we can transition into that now. If we go here to the online ML tool, this will allow us to upload our data. So we'll start by doing that.
So now, as Jacob is loading this, basically this is not a stored model. This is a model you would build using the tool. So whatever data you want to pick, based on your field, you're loading the tool in an Excel format, and you're loading the data in Excel format, and it's showing up on the website. So we're taking the house prediction model as an example. We're loading it all over. There's housing.csv, as you can see the file, and automatically it loads the columns. It's showing us the columns that are there. And from there, we can build our own model. So that we're building the model, there are kind of two major phases. There's training and there is testing. So basically training is I'm giving the model all the data and it's trying to find its own logic and patterns. And it's going, oh yeah, so stop signs are red. It's trying to kind of find all those patterns. Maybe with housing, it's going, okay, as the room number grows, it increases by maybe 100,000, except from 4 to 5, or after, maybe it's a little bit less gain. So it's trying to kind of recognize all these patterns from the data on its own. There are different, of course, ways to train. You can choose training based on some columns and skipping some columns. Maybe there's a column that you feel doesn't really affect the result. So I'm going to skip it. I'm not going to give the system more data to play around with. I can pick that. I can pick the attributes here. And then I can pick the training parameters. And that's kind of, it's a bit of background in machine learning, but we really made it in a way that is seamless and doesn't need details on.
So for example, right, let's see you are a business major and one of your areas you're interested in is help a bank to find whether you should give loan to some people or not, right? So rather than the house, you can have the applicant's status and historical data about if the person paid the loan back on time or not. So using that data, train the model. And later when you have the new data kicks in, like new customers who apply the things, it's probably cost manpower, let's see, 5 hours, machine only 2 seconds. And they can tell you by how much confident you think the guy will pay you back or not. Right, that makes sense, the idea of application. Yeah. And also another important thing is when the Dr. Abusharkh give us the explanations, oh, maybe it's a red, or maybe it's how we understand. Machine probably understand a totally different way, and we don't know. That's a little bit scary part. It's like a black box. Somehow machine connect by which specific way we actually don't know. But somehow they just find the linkage between the goal and the raw materials. Somehow they build the linkage. Even though we don't know the specific details, but we have a high confidence that we can control them and manipulate them in a way, right? Everyone okay with that? Yeah, you can go ahead.
Yep. So say for housing data, we'll say probably the age is important, right? Bedrooms. And then just to mix it up from the previous one, we'll throw in ocean proximity. So this being California, this data set has whether or not it's near the bay or near the beach. So less than an hour away. You could say if it's close to the ocean, it's probably more expensive. This obviously isn't a number, so we're going to change the type there. We'll keep this the same. We're going to say we want to predict the house value. So this says how much each house is worth here. So that's what we want to predict. What we're predicting is a number. So you'd pick label or classification if it's like a class or a group. So for stop signs, or for signs in general, I guess it can be like a stop sign or like a speed limit sign. In this case, we're predicting a number. You can see houses prices of like a continuous value. So we'll set this. There's a couple different types of models we can pick from. We'll just stick with decision tree. And then we hit train. So we can see training completed. And we can immediately go and start using this model and testing it out. So again, let's say 3 bedrooms, 20 years old or something, and then we'll just say near bay still. This one is pretty expensive, like 400,000. Yeah, so that is the online tool for making models. I think we have one more thing to show, right? The text generation.
Yeah. And then to add to what Jacob said, so the tool also has the capability to store your model, so you can come back to it and play around with it later or test it or upload your data. So it's a kind of a customized tool. We're trying to also protect the privacy of your model. Data is really, really valuable these days. So if you're uploading a model or your data within the tool, it'll be under your username only. Now, the next one is a bit exciting. So this, it's a text generator. I'll let Jacob kind of explain it, but Jacob, maybe after an example, we'll kind of solicit examples from the room as well.
Yep. So basically what this is a group called OpenAI trained a model that tries to predict the next letter after a series of text. So you can imagine if you had like TRAI, what would be the next letter? Maybe N, so that it's train, or L for like trail. And it basically just goes through and does that a whole bunch of times and will give you a unique generated piece of text, basically, that continues what you write. So
this is a predictor. So we're going to feed it what we call a seed, and then it will try to predict what would the rest of it be there. This obviously has a lot of applications, but let's see first what it generates.
I will also say we're not liable for whatever it outputs. So this one it kept pretty short, I guess. What's this one say? Welcome to the Hatch conference table. The following are some key topics that need to be discussed. When and why do we use the term cognitive dissonance?
So this is text generated by AI, right? So it's pretty good that it's kind of adjacent to the topic at least, and the only input it had is the words "Welcome to Hatched Conference." That's it, and it's trying to guess what would you say or what's the continuance of this speech. So how this works is it trains on millions and millions of text content, articles, paragraphs, reads websites, reads a lot of things, and then it tries to figure out how to continue or how to finish up a statement. So that's kind of the logic there. Again, there's no explicit programming, so I'm not teaching it, if you see a subject, follow it with a verb. It's just learning from what it saw before. And this is, the data behind it is, incredibly huge, but it's kind of, hopefully interesting. So let's ask the group, what would you like us to seed the model? Suggestions for 3-4 words or for a statement. Anything.
Put in the word anything, see what it says. Anything, okay.
And give us a statement. So just the one word, it's probably just anything can happen.
Sure.
Anything can happen.
Two things here. One is it really depends on the data set that you fit in, right? It's pretty much obvious. Like for instance, you can fit in English and ask questions in Spanish. Guess what? The machine don't care. They can still run it, okay? It's just the answer is a little bit weird. And second, depend on how much information you give, the more information you give, the better they can guess what do you want to write. So for instance, if we have someone who like to write as Martin Luther King, right? You just feed Martin Luther King's data, all his previous book and everything, then it can let AI to write a whole Martin Luther King speech, and guess what? People cannot tell. It looks like just as if this is a real authentic, paper, and this is something really interesting, too.
Yeah, I was just curious. I want to see, given like the most generic information ever, just to see what we come up with by default.
That was a good example. I mean, for the most part, some people are happy about it. I mean, it's this. You notice here, it's beyond putting together correct words, like correct words that are out of the dictionary. It's beyond putting together statements or sentences that make sense. It's beyond putting together related sentences. And then the next level is, all right, related sentences to the content that we gave it. So that is all only from training from seeing. That's it. There is no explicit programming. And that's how AI is different than, would you say, explicit programming or automation of regular programming. You're not writing any rules. It's just recognizing what's in the text that we give it.
And like, for example, here you actually see two things generated, right? Sometimes you can see a multiple. So for instance, they can even tell a story, like we just see anything can happen, and then you see someone in the interview with Boston Herd. It sounds as if something happened, right? So it's quite mad, with creativity in a way, yeah. And
Awesome. One more example. Anybody? Yeah.
So what's the difference between this analysis and the API?
What's the difference
What's
between
the difference between the API and the logic that we're using?
the API and the logic that we use?
Yeah.
So when you say API, do you mean like a backend development or ready application?
Yeah,
Right.
because it's like a business logic API.
Right. So the difference here, with business logic, I have to go in and say, this word is valid in the dictionary. This word is not valid. The system knows before. So when I give it a word, it goes and checks, is it in my dictionary or not? So I'm programming it explicitly. That's what I've been saying. We're going, the sentence has subject, verb, object. You're explicitly telling the system and it's checking against those rules. You're writing long code to do that. However, machine learning algorithms work in a different way. Machine learning algorithms are in essence pattern recognition algorithms. So the same algorithm works for image recognition for all the applications we just showed today. It's the same idea behind image recognition, finance data, text generation. It's trying to match data with a result. So in this case, the data or like the observation with the result. In the case of the image recognition, the observation is the traffic sign. The result is the name of the traffic sign. In the case of text generation, the observation is previous text. The result is what is coming after. So to the machine learning algorithm, it doesn't really care what the data is about. It doesn't know what the data is about. It's just trying to match result with information or with data. So that's a difference. With business logic, we need to have a domain expert. We need to have someone who goes, oh, the text works, and then you have probably someone in linguistics to go and say, yeah, if someone says anything can happen, probably it's a general statement or a generic statement. I have to bring something that is generic, et cetera, et cetera.
so for instance, to give one illustration, let's see, you guys all play with Siri, right? So if you say, hey Siri, tell me a joke. Traditionally, what people will do is they will pre-plant a joke over there. So when you say, give me a joke, they will, let's say 1,000 joke over there, you pick one, right, and give to the people. The difference here is we can generate one. So rather than 1,000, we can have 10 million. It's just out of the 10 million, some jokes are funny, some jokes are not. So, right, that makes sense. But the difference is, in the previous case, people has to pre-written this 1,000 jokes, and that's a lot of work. Here we can finish them in like seconds, and that's the difference, right?
So we're putting comedians out of work, is what he's saying. All right, Jacob, or it's yours.
Yeah, I mean, I think this is pretty much it, right?
Yeah. If you want to show the page with the resources.
Yeah.
So on the website as well, we have a page with multiple resources, top frameworks, as in tools that are ready for you to use directly, and they're really easy to use. Some of them are drag and drop as well. Top databases, data sources, whatever your field is, chances are you'll find a data set that fits what you need, and you can write a paper or build a project or build a product, a software product that utilizes that. These are some of the top data websites that you'll find your field. And we're here to help you as well. So part of this project is to solicit project ideas from the community at Ferris. If you want us to build a model for you, if you want us to tell you where to find the data, if you want us to lead you through just building a machine learning smart model, we are here to help. Just connect with us and we'll be happy to help. Awesome. Thank you very much, Jacob. Thanks for the demo. I want to open the floor for questions if there are any, or just, general remarks. What do you think of what we did?
I've got a question.
Sure thing.
So that second model that you guys showed, it's a multiple linear regression model, but how do you determine the dependability or the reliability of the model? And are you able to get an output of the R squared adjusted to see
Of
how
course.
reliable it is and see whether the variables that you feed? Because you can run it through, like say IBM SPSS modeler, and you can determine which variables are going to create the best model. But if you're picking the ones, is there a way to get an idea of what the ones you're picking produces overall model?
Excellent question. So this tool is trying to be an interface on top of model runners like SPSS. In this case, we're using a Python tool called scikit-learn. So it's more of a, you can control that if this is, we're kind of built it for the general or most of the audience, but we can add to it any controls that we want. The scikit-learn library for linear regression has all of it, what you mentioned, has a lot of control, a ton of output and parameters to control. But when you're building an interface, you're trying to kind of make it somewhere in the middle of the spectrum between kind of presentable and having everything. But that's a good note, and I'll try and add it.
Can we let him reopen the page so that?
Yeah, I can do that.
Yeah, please. Okay, so let me add something to it. So first, when we have the tool, right? It's not like we will beat Microsoft. We've also beat SPSS, IBM. No, okay. That's not our purpose. It's more like this. When you only have 5 minutes, do you want to have some insight first or not? It's kind of like get some hinge. And then if you say, oh, I really have interest in diversity with multiple linear regression rather than logistic, then you have to call the professional tools and digs in detailing, right? Does that make sense? But the benefit of this is to give you an overall idea of, let's see, for instance, if you run your own model, okay? You build one, it costs you, let's say, 2 hours. You try all 10, that's 20 hours. Here, only 5 minutes, you had the result from everything. And you can pick the specific tools you like, and then you continue. We are not trying to give you one-stop solution for all the questions. That's like at least impossible for us to be handled right now. But rather, we give you some initial ideas. For instance, as you guys can tell, even though AI can generate hundreds, thousands of, let's see, jokes or text or articles for us, but most of them doesn't make too much sense, right? So in other words, it has to be combined work. So for instance, many students probably worry about, oh, AI is going to steal our jobs. Well, yes, that's the challenge, but the opportunity is also there, which means if you are the person who not only be expert in your own field, but also know AI in a way, then you actually gain a huge advantage right there. Yes? Okay, remember, the wealth on this planet are not going to disappear. The only thing it will do is shift from one people's hand to another people's hand, right? Yes, it's not going to disappear. So in other words, one is a challenge for many people, and some people will actually get more benefit in a way. So the question is, are you able to cope with this challenge and the tools and technologies so that it becomes your advantage rather than your disadvantage? Does that make sense? Yeah, because for instance, in your previous question, you mentioned, let's see, R square adjusted, but in multiple linear regression, there's just so many different ideas, algorithms, such as price statistics, CP, scoop CP, so on and so forth. So it is impossible for you to run one model and get a final answer. So rather that is also why the companies always has to hire you. Because if it is one thing done deal, right? Why do you have to pay this $143,000 as average to hire you guys to do the jobs? Because it has to be followed up. It has to be updated, right? Whenever we have a new data set, someone has to take it over. And that is why those people will never be out of jobs, right? Does that make sense to you? Thanks for the question. Any other questions?
Is this going to be available to students, just out of curiosity?
Sure, of course.
We're hosting it soon, and we'll announce it at Ferris. We're kind of finalizing it, and it'll be hosted and open.
Okay.
Yeah. Other questions about the field, about the tools, the skills?
Yes, go ahead.
I'll ask one, I guess. Since I'm in cybersecurity right now, so security is my interest. I talked to you, of course, Mr. Drew, about just everything that's been going on. I had a question for our host here, who's hosting the program. Does this use SQL tables?
Yeah, of course, there's a database behind it, yeah.
Could I put a drop table statement in there?
Well, there's nowhere where you can fill in a statement within the code. It's mostly drag and drop. So,
Okay. So I was just seeing through the example, I'm seeing the text go through here, but yeah, I was wondering just from the point of security, is there anywhere I could try and put a drop table statement and see low? Not, of course, I wouldn't do that now, but.
yeah,
say
no,
just
understood. I'm trying to guess because the drop table statement would be, in a request, in a web request, but there's no way where you're sending a web request here directly. Only through the text generator, you're sending the text itself, but it's read as an input for an ML model. But that's something to keep thinking about. That's a good idea. That's a good thing to.
Yeah, actually, we really welcome interdisciplinary. So for instance, yes, we are doing data science, but that means the data that we generated or the data set that we gained from, we don't need security. Of course, no. Cybersecurity also very important. So that is also something we try to embrace here because we really welcome interdisciplinary. We are not talking about one thing replace all. We are talking about how we can collaborate everything. So again, it can towards our benefit, it can towards our advantage rather than towards our disadvantage, right? So that's very, very valuable input. Okay. Thanks.
So before we wrap up, I just want to thank Jacob for his amazing work. Most of the development was done by our team of students. Jacob is leading that. This is a set of skills that you learn at Ferris that you can build on your own. We help you there step by step, but it's very manageable for undergraduate students and for graduate students after. And I want to also give a big thanks to our, the college and to Ferris, and especially to the Extended International Operations for the support for the project and for the Innovation and Development Grant to give us the opportunity to do all of that and kind of use the grant money for something that's hopefully interesting to you guys. Thank you very much for listening, and feel free to reach out to us about any question about the tool. And have a great day, everybody.
This will be for launch.
Oh, thank you.
Thank you. Where's the moment? And I was like, I'll leave them and I think Ian will be able to like translate. How are you? Good. Minus the cool thing. Listen, I thought I had it under control and I looked coming back and like, oh, I'm not yet. Yeah, or I can. I'm gonna have to go up there anyway.
Thank you.
Thank you.
I'm glad you like this. Yeah, the lab, yes, the lab I found it. Yes.
Nice to meet you.
Yeah, that's all good questions.
I'm Jennifer. You know her. I've been processing your payments.
Oh, thank you so
And,
much.
Also part of the Office of Graduate Studies, we've already met with Ilias to
Oh,
be
great.
ready the minute